Hello, hello. And as Michael said when he put this puzzle up on one of our servers, apologies to Frank Sinatra for that intro. Today's puzzle is Come Fly With Me by Michael Lefkowitz and Shintaro Fushida Hardy, the latter of which I'm not familiar with, but I have done and talked to Michael a number of times, and so I'm sure this puzzle is going to be great. The art is just absolutely fabulous on it. And with a title like that, how could I resist? My dad was I think like most Italian American men of a certain generation was a big Sinatra fan. So we're gonna give this puzzle a shot and see how it goes. So what are the rules? So normal Sudoku rules apply, which means that in every row, every column, and every 3x3 box, we're gonna have the digits 1 to 9 exactly once. And now we have dewdrops. Okay, so these are like crocky dots. Dewdrops indicate the difference between the cells. So there's going to be a difference between two of the digits on these cells because there are two dewdrops. Two dewdrops. That's hard to pronounce well. This is 3 dewdrops, so that difference will be 3. Difference will be 1, etc. I guess that's all of them. Now we've got two different kinds of animals: spiders and flies. A digit on a spider indicates how many cells with smaller digits exist in the same web. So I first saw this puzzle was actually on my phone, but now that I've opened it on my desktop, I actually see that the webs are actually all slightly different colors, which is very, very cool. But you can, they also just don't quite touch. So like this is a web, this is a different web. Look like these 9 cells are another web. So a spider on a web is going to count the number of digits smaller than itself. I'd be careful about trying to do an example because I might, figure something out or whatever. Well, it doesn't matter. So suppose this were a 6. What that would mean is that there are 6 digits less than 6 on this web. So these might be 1, 2, 3, 4, 5. That would be 5 digits less than 6, and then one of these. So maybe this would be 1. And these might be higher, right? So these might be a 7, 8 pair or something, right? So something like that could work because this 6 counts these 6 digits on the same web, which are all less than 6. So that's what spiders do. And flies, I think, are the opposite, right? So yeah, fly on a web indicates how many cells with larger digits exist on the same web. So if this were, say, let's do 5 again, we might get 6, 7, 8, 9 here. We might get a 9 here, and then something like 1, 2 here. So these 5 digits would be more than 5. That would satisfy the fly. All possible spiders and flies have been given. So there's a negative constraint on the webs for spiders and flies. I assume I don't have to think about what that means on a non-web because it would just be 0 or some weird thing. So I'm not going to worry about that. Let's see how it works. And where to start? So the thing that I'm thinking about are webs that take up either an entire column, like here, or an entire box. I don't think I need to take up an entire row. So what are these? I think these webs are going to be important to start, because I know what digits are on this web, which are the digits 1 to 9. So let's say I didn't have this little appendage here. Let's look at column 3, and suppose there were no extra web. It was just the digits 1 to 9 on this web. What could I put in this spider and fly? In fact, I don't think the spider would work at all. Because let's say I put it really doesn't matter what I put in here. Let's say I put a 6. I guess I can't put a 1, but other than 1, suppose I put a 6. I'll explain why no 1 in a second. These digits contain for sure a 1, 2, 3, 4, 5. So there would be 5 digits less than 6 on this web, which is not 6. So it just wouldn't work. So I need to have exactly 1 digit less than, in this case, 6 in the appendage of the web, in the extra bits. And I think that's it. So that means and the reason this can't be 1, none of the spiders can be 1 actually, is there are no digits less than 1. So I can never count a digit less than 1. So I'm always going to count 0 digits less than 1, so 1 cannot possibly work. 2 could work because I could have a 2 here. Somewhere up here is a 1, let's say it's here. And then somewhere on this I could put a 1, let's say it's here. And that would work fine. Now going the other way, it's not the same. Because I don't know how many digits less than this spider. Oh, no. It is, well, I need to be careful here because no, it doesn't matter. Yeah, here it's exactly the same actually, which is strange. Let's say this is 6. Well, on this the same web, I have a column 1 to 9 with the digits 1 to 5 in particular on it for sure. So this is going to count 5 digits less than itself. And I need 1 more here, which is not itself, less than it. So this spider here in row 5, column 6 is greater than exactly 1 of those 2 digits. That much I know. And this digit on row 9, column 3 is greater than exactly 1 of these. And now it can't be this one, because if, like, let's say this were 5 and this were 4. Well, this digit is greater, and so in this case, this 5 is greater than 4. And that would mean it couldn't be greater than either of these, because then it would count 4 digits here, a 5th one, and a 6th one if it were greater than another digit. But this spider is greater than 1 of these digits. So this one of these digits is 1, 2, or 3, which will also be less than here. So that doesn't work. So these 2 spiders are both greater than exactly 1 of these 2 digits. And I'm tempted to say that means they're the same digit. But I don't think that's quite true, right? Like I could do 4, this could be a bigger one. And then I could have 3 or something and 7, right? So I think this works because this would take 1, 2, 3, another 3, that's 4 digits. This would take 1, 2, 3, 4, and 3. Yeah, that does. So these don't have to be the same. This can be bigger than this, and that's okay. So the order of digits is I've got a low digit in one of these 2 cells. And that low could be 7, right? But the lowest of these 3 digits. And then I have this digit, which is weakly lower than this digit, which is strictly lower than the highest digit of these 3. Okay, but that's all I know. But I think that logic is going to apply here and here. Here I'm going to have to worry because I'm missing a cell in the 9. And so, I mean, well, I guess we'll get there. Let's think about flies. So what can this fly be? Well, it can't be less than or equal to 4, because a 4 on a fly here would see 5 digits higher than it just from the line, so that doesn't work. So this is at least 5. Can it be 7? I think not, because 7 could see 2 digits higher than it here. In theory, 3 digits higher than it here, although that's not really going to work with the spider, I think. So it can't be 7. Does 6 even work? 6 sees 3 digits lower than itself here. And I guess I could, so if this is 6, this is 7, 8, 9. Is that possible? The spider would have to be 8, and this spider would have to be 8. But I think that's okay. So I think that works. So this is 5 or 6. I think by the same token that means this fly is 5 or 6. Is that right? It's the exact same logic, right? There's no difference between these essentially. I've got 3 with a spider on it, 3 with a spider on it. Yeah. Now, importantly, these can't both be 6, because if either fly is 6, the spiders on the web become 8, because if the fly is a 6, the extension becomes a 7, 8, 9 triple, and the spider has to be the middle of the 3 digits. So the spider is going to be an 8. And so if these are both 6s, these are both 8s. Now these could be both 5s. I don't think there's anything restricting that. Okay, let's think about this fly. It's in here with this spider. This fly cannot be 1. Yeah, this is a 2, I think. So this cannot be 1 because both of these digits will be greater than 1. So it count 2 digits greater than 1. That doesn't work. 2 doesn't. Oh, 2. Yeah, 2 works because all that would mean is there's no 1 on here. I'd have 2 digits more than 2, and that would work. 3 doesn't work because there's only 2 digits I can possibly count. So this is a 2. Okay, our first digit is actually this fly on this little tiny web. Are there other little tiny webs that I can do something with? I don't see any. Let's think about, that doesn't impact this at all. Okay, let's think about this. This is actually really strange. So this, does this now have to be 5? It can't be 4 because I've got 5 digits higher than 4 on the web. So this is at least 5. But if it's 6, I would need 3 digits higher than it on the extension, which it can't be. So this actually is a 5. And this is bigger than 5. Which almost makes this not 7, 8, 9, but it could still be 7, 8, 9 if that's 6. 1 would have to go here. Yeah, it just barely works. So but how do these 3 spiders work? Because, hold on. All 3 of these spiders, yeah, no, okay. These are, okay, I get it. So these 3 spiders all have the same property where they're higher than, so if this spider is n, say it's 7, doesn't matter what it is, pick a number. It's higher than n minus 1, 6 if that's 7, in the web. And then it needs 1 more outside of the web, which means these 3, and that's true for any spider, it doesn't matter. So these 3 spiders are all bigger than this cell, which means that's 6, and this is a 7, 8, 9 triple. Which is just bananas. So and then this is 3, it's got to be greater than, because even from 7, 3 more is 10, doesn't work. So this is 3 greater than whatever's here. So that's 4, 6, because it can't be 5. And now we can still have 7, 8, 9 here. No, I can't have 7, 8, 9 here because this looks at this. This 7, 8, 9 looks at this spider. So now this is a 5. And this spider is greater than exactly one of these. And this is no more than, okay, this is actually pretty small. So this is 3, 4, or 5. Because it can't be 6, 7, 8, 9. It can't be 2. And it can't be 1 because it has to be bigger than something. So this is bigger than exactly one of these digits. So there's a 1 or 3 or a 4 that this is bigger than. And this has to be no more than this. So this actually is 2, 3, or 4. Because it can't be 1, so it's got to be bigger than something on here. And it can't be bigger than this. It could be the same as this, but there's a 5 here. Can I do something with this? This is a cropped out, essentially. It can't be more than 4, right? I guess 5, 7, 8, 9. I can't put a 6 in here because we need a 5. So these are something in 1, 2, 3, 4. Can I get 1 more in 1, 2, 3, 4? Probably not. What is the next thing? Oh, this is, in my head, this is part of this big web. This is a small web. What is this fly? It can't be more than 3 because there are only 3 other cells here. It can't be 1 because all 3 of these are bigger than 1. It could be 3. These could be 3. It could be 2, and I would just need 2 cells bigger than 2. So 1 would be, if this is 2, there's a 1 on here. If this is 3, there's no 1 or 2 on here. But the 3 dewdrops is also interesting because it has to be bigger. So that's 5 or 6. Oh, and 6 is taken. So that's 5. That's 2. So now there's no 1 on here, is the only thing I know from the fly. I can't have a spider on here. Yeah, a spider needs extra digits it can't see to work. So I couldn't possibly put spiders. So like the negative constraint on spiders here and here isn't really doing much. Oh, what about the negative constraint on spiders here? Is that doing anything? I think, what is that doing? That's saying that, what is that saying? That's saying that this digit is exactly 1 more than this, I think. Let me think, because if this were 4, say, and this were 1, yeah. I almost said that means this can't be 1, but this could be 2. So this digit has to be exactly 1 more than the digit it's bigger than, which means it's not 3. Because if it weren't, I should have another spider, right? If this were 4 and there were 1 here, wherever the 3 is should be a spider, and wherever the 2 is should be a spider. But they're not spiders, so that wouldn't work. So somewhere in here there's either a 1 or a 3. That doesn't apply over here because I don't know that every digit is on this. Oh, hold on. But like if this were, oh, and this will be bigger than 2, so that also would be a spider. Okay, yeah. That so the bigger digit will count the n-1 less than it and the 2 less than it over here. Okay. I'm satisfied with that. No 1 on this. 1 is in here somewhere. 1's in here. So 1 is on this. I'll mark it there. But 1 is not on a spider, we said. Okay, how is this going to work? This is definitely bigger than 1. It might need to be bigger than 2 digits. If this is bigger than this, it's going to be bigger than 2 of these digits. If this is less than this, it'll take the 1 and not the other digit. But these are all fairly small, 2, 3, 4, 5. I mean, this could be a 2 and it would just be done. And in fact, one of these is a 2. Like from Sudoku, I know. There's a 2 here and a 2 here. Yeah, it's probably going to end up being a 2. Okay. 1 or a 3 is here. Okay, let's try this web for a second. Because this has 2 spiders on it. And 2 spiders over here. How is this going to work? It feels too complicated. I'm not ready. I'm not ready to look at that. Maybe maybe the fly. No, I don't know. How about this fly? This fly still can't be 7 because at best then we're getting 2, we're getting 5. So it's less than 7. 6, 3, 7, 8, 9 doesn't work. 5, I could get 4, 5, that works. Could 4 work now? 4 can work because I had too many here. 4 might work here if this is a 1, 2, 3, or 4. Because then the 4, and then this could be big. So this is 4 or 5, I think. 3 doesn't work because I have way more than 3 digits, even if I take away 1, that are more than 3. 4 just barely works if none of these are bigger than 4, which is possible, and this is more than 4. Otherwise, it's got to be 5. And if it's 5, oh wait, can it not be 5? Because I could get 4 here. I need 1 bigger than 5 here, but everything bigger than 5 is taken actually. So this is just 4. So these are from, this is 2 or 3. These are from 1, 2, 3, and 4, which means 5 is definitely here. And then this is bigger than 5, which means this cell, this needs to take 2 digits lower than it because it's not taking this one. So it's taking n-1 of these digits, n-2. So this is a 3. No, sorry, I'm wrong, other way. This is bigger. So this is 3, it's getting 2 digits from this, and it needs 1 more. If this is 2, it's getting the 1 from here and the 1 from here. In fact, it can't be the 3 because I need a 2 on this. So this is just a 2. The 1 is less than it. The 1 is over here. It all works out. This is going to be bigger than... I don't think I can do anything, right? So like, let's say this were 6. I would get 4 digits less than it here if this were 5. I get 4 here, but then I would need only 2 of these digits to be less than it, but all 3 would be if it were 6. So it can't be 6 plus, which means it's pretty low, which means it's lower than this. So this is 1, 2, or 3, not a 1, so 2 or 3. And this is going to take both, it's got to be bigger than exactly 1 digit here, so that's 2 as well. Because the 1 is here. If it were 3, it'd be bigger than 2. So that doesn't work. 2 is one of these digits now. Then what? Not sure. I kind of have a virtual 4 pair here because I've even on the crop key, which is 2 or 4. This is 2 or 4. So this is either odd or fairly high. Let's see, what could this be? It can't be 1. It could be 3, 5, 6, 7, or 8. If it's 8, I would need 7, 9. Yeah, I mean, that's a lot of digits. Okay. 5's over here. This is tough. This could be 7, 9. This 5, 6 is creating a bit of a barrier here. So it's either 7, 9 or 1, 3 or 2, 4. But any of those, that's still a lot of choices. Okay. Okay, if this is 4, we get a 3 here. I'm wondering if these could be different. Like, could this be 5? Okay, can this be 6? If this is 6, that's 8. We get a 7, 9 here. Um, 7, 8, 9. This would have to become a 1, 2, and a 3, 4 somehow. 2 would go here. Actually, oh, 2 is on this. Oh, there we go. 2 by Sudoku is on this. So this is a 2, 4 pair. And I know how that goes. Which means I have a 2 here. And a 4 here. Then, and I can say the same thing about the negative constraint here is here, where this digit is going to be exactly 1 greater than the lowest digit on this extension. So there's no 1 on this extension because I would require this to be a 2. And there's no 3 because I would require this to be a 4. There's no 2, there's a 2, there's a 4. So actually the lowest digit that's possibly here is 5. Which means if this is 5, I have at least 2 digits higher than 5 here. 4 from this, that doesn't work. This is a 6. Wow, that is some very nice setting. And then this has to be 8 because it has to be exactly 1 higher than the lowest here. Seven, I don't know. I think I might be out. There's a 6 here. There's an 8 here. Yeah, I don't don't see anything else. Okay. I think we're gonna have to attack this now. But it's so complicated. I don't even know where to start. I have two spiders that work, which have to be different digits. So let's think about the bigger spider for a second. No, I don't know. How do I think about this? These spiders are at least 3. These spiders are at least 3. And they have to be more than most of these digits. Well, I mean, most is too strong maybe, but they've got to be bigger than some of these other digits because like the bigger of these two spiders is at least 4. And these spiders, hold on, maybe I should think about this fly for a second. Because these spiders, they can't be 1 or 2. So these spiders are at least 3. This fly can't be 1, because a bunch is more than 1. It can't be 2. Could it be 3? I get at least 1 from here, and at least 3 from here. That doesn't work, because even if these were as small as possible, 1 to 6. That would have 3 digits higher than 3. And then I could have the lowest here would be 1, 4, which is a 4th digit. So this can't be 3. 4 will work. 5, not 6. Could it possibly be 7? No, because I would need 3 digits here, 2 digits here. That's the best I could do. It's only 5. So this is a 4, I think. I think that's right. And then I get a 4 on this, which can't be the lowest digit because of this. And this can't be the lowest digit. Oh, but I get 4, 3, 1, I think. Still works. I was saying this couldn't be 3, but maybe this can't be 4. If this is 5, the 4 on here will be the lower of it. And then this couldn't be higher than the 4. Yeah, so this isn't 5, actually. That's 5. I thought I tried to put something else here, too. Is this 5 and what? No, I don't know yet. It's just got a 5. 1, 3, 7, 9. Yeah, I don't know. Okay. This is 3 or 4. If it's 3, that is 2, and there's a 1 on here. So it could be 3, 4, 1, or this could be 4. This could still be 4 or 2 in that case. If it's 4, we'd need a 3. If it's 2, we'd need a 1. And then something bigger than this. Okay. I don't know. Okay, let's go back to these. Because now I've got a 4 here. I've got 2 spiders and another. Let's think about this fly. The flies, I think, are actually more useful. But this one doesn't see as many digits. So this could be 2, 1. No, this can't be 3. Because this needs, if it's a 3, I'd have, for the same reason this couldn't be a 3. I get at least 3 digits higher than 3 here, and at least 1 digit higher than 3 here. The 4 is right there. So this is at least 4. It can't be 5. And it can't be 7 for the reason this couldn't be. I can get at most 3 and 2, which is 5. Can it be 6? I would have 2 and 4. No, 3. I can only have 3 digits here more than that. So it can't be 6. That's a 4 as well. Okay, and then the spiders. How do the spiders work? Or maybe I should think about what digits are actually bigger than the 4 on the fly. Because it's the same 4 digits on both. So of these 7 cells, oh, that's the way to think about it. Of these 7 cells, 3 are less than 4. Of these 7 cells, 3 are less than 4. So if 3 are less than 4, which sounds like I'm saying a very obvious fact, like 3 is less than 4. But 3 of these 7 cells are less than 4. So 3 of these cells are in the 1, 2, 3 category. And 4 of them are in the 5 plus category. Which means my spiders can't be 1, 2, or 3, because I could never, even at a 3, the 3 couldn't count itself, so I only have 2 other digits that it was bigger than. So the spiders are at least 5. So these spiders are actually quite big. This one's 6, 7, 9. This one's 7, 8, 9. Do these spiders have to be like a descending pattern or something? This is, hold on, this is 6, 7, 8, 9. This is 5, 6, 7, 8. Because, well, I guess these could be the same. So how do these spiders work? Like, let's say this is 9. 6. Oh, it can't be 9 because I only have 8 other cells I can be bigger than. So, yeah, I think these are, well, does this have to be 5? I think these have to descend roughly with something weird about the extra one. What about the one that's not, that doesn't see all the, like this cell, this spider doesn't see all the other spiders. Like this doesn't see this and this doesn't see this. So these could be the same. Or can they? Does that break both of them instead of fix both of them? So if this is, let's say this is 8. That means 1, 2, 3, 4, 5, 6, 7, 8. So there is going to be a 9 somewhere here to make the 8 spider work. Assuming there's an 8 spider. Maybe I should do it that way. Suppose there's no 8 spider. Then the biggest spider is 7. Let's say it's here. Then there's got to be an 8 somewhere. This 7 would be bigger than 1, 2. Oh no, I could have 2 7s. If these are both 7, I could have 2 cells, and then let's say that's the 9. Then they could all be bigger than 1, 2, 3, 4, 5. Oh, did I miscount? 1, 2, 3, 4, 5, 6, 7, 8. No, that's not necessarily a 9. That was bad. Bad logic. Okay. If there's an 8, it's bigger than every other spider here. So if there's an 8, everything else is 1 to 7. So there cannot be 2 8s. There cannot be 2 8s. If there's no 8, then maybe there's a 7. And then maybe there's an 8. Maybe there's an 8 off of it. Or maybe there's a second 7, and they're both bigger than all the other 6 cells. Okay, let's think about this. There has to be a smallest spider. It could be a tie, but there has to be a smallest spider. And the smallest spider doesn't eat or is not bigger than any of the other spiders. So that spider can take at most 5. So there's a smallest spider that's no bigger than 5. There can't be no 5. Because if there were no 5, all the spiders would be bigger than 5. That has to be at least 6. But there is a smallest spider which is not bigger than any of the other spiders. Weakly smallest. So that's a 5. And now the problem is, I mean, if these didn't all see each other, I think they could all be 6, and that would work fine. Wait, and this spider's 5. So these are all from, this is a 1, 2, 3 set. So that's the 2, and this is 1, 3. This 5 is bigger than these 5 digits. It's not bigger than these. If I have, if this is 6, it could be 6, 7, 8. It could be 6, 6, 8. It could be 6, 7, 7. If this is 8, I think it could be 8, 7, 6 too. Yeah, okay. Lots of different choices here. But that was pretty big. It was pretty good. I've got a 1, 3 pair here now. So these are all quite big. Um, 7, 9 pair looks here. 6 looks at this. One of these is definitely a 6. I should mark that. Actually, what's in this column? I got 7, 8, 9, 2, 4. These are 1, 3, 5, 6. And there's no 6 here. So these are from, this is 1 or 3. 7 and 9 appear there somewhere. Okay. Did I miss any dewdrops? This is going to resolve with the dewdrop. That's done. That's done. This. Oh, this can't be 4 because the 2-4 virtual pair we talked about. This can't be 1 because this can't be 2. Small victories. 2 is somewhere here. Okay. Wait, hold on. This fly, I forgot about the fly on this. This fly needs something, a 7, 8, or 9 here, and not an 8. So this fly needs a 7 or 9 here. So this can't be 3, 4, 1. So if this, I think this can't be 3 then, right? If this is 3, then there has to be something less than a 3. This would have to be 2, because this spider can't be bigger than this spider, or it would be bigger than 2 digits over here. So if this is 3, this is 2, 3 would need a 1. We need a 4 here by Sudoku. This would be 4, 3, 1, and the fly would break. So this is the 4. This is a 1, 3 pair now, which is not really helpful because the rest of the column is done. 4 is in here. And this is 6, 7, 8, 9, I guess. I need another 1 or 3. Oh no, 1, 3 is not there. So this digit is in one of those spots. There's no 1 here. 1 is down here. This could be 2, 1, or it's 4, 3, 1, 7, 8, 9. I want to put 7, 8, 9 right here, but I think this could be 3 as well. Right, this could be 3, this could be 1, and this could be 2. And then I'd have 7, 8, 9 in like those cells. Where do we go? Is there something with, could this, no. For this to be, yeah, the fly uniqueness I don't have to worry about. Yeah. Why is this web here? This web is here, it must be for uniqueness, and the spiders I know cannot go in a web that doesn't leave its area of vision. So this is here because there's a fly that's not on it, which could be important. What is that fly? Maybe they're just messing with me. Oh, hold on, 2 and 4 both look down here. So this is actually a 2-4 pair. Which is a little bit weird. There's definitely a 1 here. And there's definitely a 3 here because 3 is also not in this column. So this is a pretty high digit. And this is bigger than 2. It's not 4. So it's 3, 6. That's too many. It's too many digits. I wonder if I can put like a 1 here or something. Well, between 1 and 3. Okay, 1 on here. No, 1 on here is not going to matter ever. 3 on here. 3 on the web means that 1 is on the web. Because if 3 is here, if 3 is on the web somewhere, and 1 isn't. 2 is gone. So these other 3 digits would be higher than 3, and then I'd be missing a fly. And I think that's the only fly thing I need to worry about. So the reason this web is here is to prevent 3 on the web and 1 here. So why should I be tempted to put a 3 here and a 1 here? I don't know. But I bet that will come in handy later. Two, 4, and 8. Oh wait. Oh no. 2 and 4 are all done. 2 and 4 are done here. Actually, can I just do Sudoku on 2s? No, I can't. 4s? Still no. Yeah, okay. Well, I guess there's no 3 here. Oh, no, that's not true. 3 would put a 1 on the web. That would be fine, actually. No. I don't know what I'm doing. So 2, 4, 7, 9, 1, 3, 5, 6. This is all of those choices. What am I not seeing? I feel like the 2 is satisfied, the 2 is satisfied. Oh, is there a, like why? Yeah, no, none of the spiders would be set. This works. Is there a no fly? Like, there's no 5 fly because nothing's bigger than 5. Yeah, no, that works. Okay, I think this web is done. And I think this web is done. This web needs that this contains 1 less than this. Otherwise, I think it's good. And I can't have 1 and 3. Oh my goodness, this is tough. Oh, I need a 9 here because there's no 9 here. So that's a 9 because it's the only place a 9 can now go in this box. Therefore 9 goes here and here. Um, 8 here and here. 8's in one of these. Okay, let's think about these again. If this is 6, I could have 2 6s. Or I could have 6, 7, 8. If this is 7, I need a 6 somewhere. So if this is 7, that's 6. And then this could be 7 or 8. If this is an 8, we get 7, 6. Okay, I think I get how that works. I need a 9 here. I need a 9. I need a 1 or a 3, and I need this. No, not so that digit. This could be repeated here. Oh no, this can't be repeated here because it would have to go here. So this is a 6, 7, 8 triple. Which means it's 7, 6, 8, 8, either order. Yeah, okay. But this is a 7, 6, 8 triple. Does that help me somehow? Don't know. It tells me this digit is over here, is over here. So let's do some coloring. Let's call this one purple, this one orange, and this one blue. Purple's got to be, so this is a 1-3 purple triple. This is a 9 blue orange triple. Purple's in here with 9. Blue and orange are over here, and therefore over here. Where's 1? I think it depends where 3 is. Right, so here I have blue and orange. Here I have 9 and purple. And then I've got 1 and 3 in some order. We'll mark that. Sorry. Okay, what do I do now? I've got 5 down here somewhere. An 8 in here somewhere. So not here though. Okay, so 8. Oh no, 8 could be purple. Okay. Yeah, I don't know. This is 9 blue orange. 3 purple. Yeah. It just feels like they're stacked up and I can't find the last push. Is there something wrong with either 4, 3, or 2, 1? If this is 2, 1 is here and 3 is not. But 3 could go anywhere. If this is purple, 1 would go here. That seems fine. I don't know. Maybe it's time to ruminate on the titles of future puzzles I've been thinking about, because there's obviously I think you could have a whole trilogy just with Frank Sinatra tunes, and obviously there's Fly Me to the Moon. Then you could also add the less well-known Poor Butterfly, which might be more thematically appropriate if you had a butterfly caught in a web here. That's all I have to say on that. It was not enough time to come up with something good. 1 is in here. Okay, it's probably Sudoku. Let's do Sudoku. 2s, I've all set. I have no 1s in the grid. 3, I have no 3s in the grid. 4s. Oh, no. I thought I next week on 4s, but I have a 4 sneaking right there. There's some reason this can't be 4, 3. If this is 4, 3, this is 2. We get a 1 here. Actually, we get a 1 here because 1 would have to go on this. So 1 would go here. This would become 7 or 9. I know there's a 7 or... okay, on here, there's a 7 or 9. Ah, no? I almost said where is 6 on here, but it's right here. It could be purple. But there's going to be some dependency like that breaks this open. Where was I in Sudoku? Fives. 5 is one of these. These. Yeah, it's too many choices. 6s. 7s. Do I have any 7s? 8s. Okay, so on here I have 7 or 9, 1 or 3. If it's 7, I think that gets pretty gnarly. 7, 6. Where's 9 in this row? It's here. That puts a 5 here. This becomes a 1, 3 pair. It works though. Okay, if 9's on here, it really doesn't do anything. Okay, could this be 1, 2? Is there a problem with 1, 2? 1, 2, 4, 3, 1. I guess 1. I don't know. Oh no. I think I did this fly wrong. I'm really in the fly means there has to be a 1 on here. No, there can't be a 1 on here. Oh no. Okay. Let's go back. Let's see how far back I have to go to fix that. Oh, I can't believe that. Hold on. Is it just there? That's not so bad. That's not so bad. I'll go back and watch the video, but I don't think I used the there can't be 1 on this, which was wrong, until I put 1s here. And in fact, even that comes from this. Like, where's 1 in the column? It's not here because the 1, 3 pair. So it's there. Yeah. I broke the replay, but I think that's okay. So this is a 1. I think that's okay. I think we're good. And now I can't put a 3 on the web. So that's a 3. This is now a 1, 2. Oh, there, thank goodness. I was like, what am I? And it's because I just got the web backwards with the fly. Okay, I feel good about that. I mean, I don't feel good about that, but I feel okay. 3 is there. 1 is here somewhere. Okay, why did I end up with those had to be different? I don't remember. So I'm going to not assume that again until I figure out why. And there's something about where is 9 in the column or something, but I think that might have been, well, I don't know. 9, oh, 9 is here in this one. So no, that is still good. Where's 9 in the column now? It's here. This digit can't be here because it doesn't show up here. That's what it was. So these are 3 unique digits still. So these are purple. I don't remember which order I did. Blue and orange. Seems backwards to me for some reason. Orange, blue. These are blue-orange pair. Purple is in here with 9. Purple is in here with 1, 3. Okay. Now we're basically back where we are, but with a lot more digits. 1 has to go in here. Can't go to 7, 9. That's a 1. Do I know? These are, I need a 5 somewhere still. 5, 6, 7, 9. Okay. Oh, 7, 9 is here. So this is a 5, 6 pair in the row, and this is a 3. 3, 4, 6 pair. I guess that's not a 4. What now? Okay. Then this is a 4 now, so the 3 has to be on here. That's the 3 and not the 1. And 1, 3, 7, 9. 1 is up here somewhere, so not here. That's not a 1. That is a 1. These are from 3, 7, 9. Six could be either of those still. Okay, I need 7, 8, 9 here. No help. That's not 8. That's not 9. Oh, because of that. Okay, 7, 8, 9. What is this? This could be 3 still. So this is a 3, 7, 8, 9. That's what's left. 7 and 9 are definitely here with whatever's missing from the purple. 5 is here now. 6, 7, 8, 9. One of these is the 6. One of these is the 6. Yeah, no, it's not helpful. Okay. This is a 6, 8 pair. I don't think that coloring's gonna help me at all. Okay. That's done, that's done. The dewdrops are done. It's just Sudoku now. I can do Sudoku, right? History shows that I'm very good at Sudoku. That's a 3. 1. 3s are done. This 6 looks at purple now. So purple is 8. I think that's going to be all she wrote here. I should know this digit is a 1. I should know this digit is a 5. Let's go down here. These digits are 7 and 9 in this order. Whew, sorry about that. I'll go back and make sure that that didn't lead to any bad assumptions. I think I don't know if I said it right the first time. I think at some point I had the right thought here and just negated it in my mind somehow. But anyway, great puzzle. I really enjoyed it despite getting so stuck by my own bad logic. But so thanks for setting it. And yeah, thanks for watching. See you next time. Bye-bye.